So, ladies and gentlemen, welcome. In this session, we would like to install R on a Linux machine. And there's, as always, more than one way to skin a cat. So the easiest thing is, as on other systems, to install a precompiled binary. And on common Linux systems, this is pretty easy. So if you have the corresponding rights to do so on your machine, so I'm just switching in super user mode, you can here on Ubuntu or on a Debian machine just search for the RBase package. And this gives you a lot of output, maybe too much, so we grep for RBase, and here it is. So you install this package, the GNU-R Statistical Computation Graphics System. And once you install this package using apt-get install, something I will not do here on this machine because I will show you alternative ways to install R. Then you have R readily installed. So if you are using R for data analysis and you don't need really full control over the system, it's installation that means, then this is the way to go. So for the nerds in the audience, the way to install R works as follows. You point your web browser to crun rproject.org, and then there's a link, download R for Linux, and this gives you several links to precompiled binaries. This is not what we want. What we want here is the latest R release, and that means the sources of the latest R release. In our case, this is R3.1. We download this file. Takes a few seconds, and we then extract this file, or maybe I just show the file to you. So in downloads, you find this file. This is really the source file, so we extract it. It's a tart and gzipped file. And this command extracts the whole archive. And then a new directory is created, meaning with the name R310. And this directory contains everything that you need to compile R on your machine. So the main difference is you don't get a precompiled binary, but you compile it tailored to all the libraries on your machine. So the first thing we have to do is we have to configure our installation. This configure script basically browses through your system, checks if the necessary libraries, other packages like Fortran compiler and so on and so forth is installed, and sets up the makefiles. So on my system, this looks pretty good. So we have a GNU compiler installed, we have a Fortran compiler installed, a C++ compiler is there. We have the X11 and TickleTK libraries, readline is there, can produce PNG, JPEG files and so on and so forth. Our profiling is there, everything. So there's only one additional step we have to do, namely we have to say make, and now the makefile points the different compilers and linkers to the source files of R. They are compiled and finally linked. So this will take a couple of minutes, and the output is pretty uninteresting. On my machine, this would probably take like 3 to 4 minutes. So we have a small commercial break now, and we will be back in a minute when we see the results. So welcome back. Took several minutes, maybe a little more than 4. And well, now we have compiled R on this machine. And there is a binary in rbin which can be used to start the R system. So there is one important step that also applies when you installed precompiled binaries, and that is the question of how to or where to store external packages. And the place where packages are installed is called a library. So it is convenient for every user on a multi-user system to install its own library, mainly because this gives you complete control over all the packages, the R add-on packages. That means you can update the package whenever you want, or you cannot update the package. There are also reasons when you want to make sure that the whole environment is pretty stable, so you don't want to update anything. And this gives you full control, in contrast to the case where another maintainer or somebody who's in charge of the system has full control over the library. So we create a new directory, maybe libr, and then we have to make sure that our system knows about this, so we create a file called bashrc. Export rlibs equals libr. Okay, so I quickly log out. So, in fact, the file is called bashrc without any underscore. Export this environment variable, log out, and then after I log in again, I can check if it is there, and here we are. Okay, so let's give it a try. We start R, our own version of R compiled a few minutes ago, and then we install a package, maybe the package that implements multivariate normal and T distributions. We pick a mirror in Austria. So the whole magic that takes place now consists of the download of this file. So this is the source package. And then this package, more specifically the Fortran in C code contained in this package, is compiled directly tailored to our machine. And then the package is installed, and that means that we now have in libr a new directory called mvt-norm, which contains the installed package. Now we can make use of this package by attaching this package in R, and then we can run the examples corresponding to the multivariate T distribution.